Hi everyone! In this demo, we are introducing Crowd 2.0, a web-based tool for visual ontology development and support. In particular, Crowd focuses on treating interoperability in terms of interchanging ontologies as knowledge models within user-centered ontology engineering environments, involving visual and serialized representation of them. We claim that dealing with this issue would help users with diverse skills to work together in early tasks of ontology development. Ontology engineer methodologies must support all involved stakeholders, such as knowledge engineers, users, and domain experts, during the ontology life cycle. That is, from early organizational feasibility studies to the development and support of ontologies and the maintenance and use of such models. Ontology development involves tasks of analysis, conceptualization, and implementation, while support activities involve documentation, evaluation, reuse, and knowledge acquisition. In this work, we focus on particular activities in the phase of ontology development and support, such as conceptualization, implementation, reuse, and evaluation. The purpose of the ontology conceptualization is to organize and structure the knowledge into meaningful conceptual models, while the implementation activity aims at generating computable models given in terms of ontology languages. Ontology reuse allows modelers to reference concepts and properties from external ontologies. And lastly, evaluation involves making an assessment of partial ontologies. This scenario requires working on the orchestration of complex and heterogeneous representation formalisms with possibly different expressiveness power, aiming at interchange ontologies to be manipulated and visualized by diverse stakeholders and tools during the ontology lifecycle. In this demo, we showcase Crowd 2.0, which provides support for conceptualization and implementation activities, in addition to ontology soft reuse and evaluation. The tool is supported by three main ingredients: a set of visual editors for UML entity relationship and ORM2, an underlying metamodel named KF, which is a common interface between different representation formalisms, and finally a set of logic-based reasoners to evaluate the models. Thus, any interaction in the workflow of Crowd must go through such metamodel before being manipulated by other tools. The framework developed implements the interaction between a Crowd client and multiple applications on the server side via web method calls. The client is a web application implemented with Angular framework and JavaScript plugins. The server is composed of three main applications: a Node.js application named Crowd Server for connecting the MongoDB's database, a Java application named KF API, which implements the KF interoperability rules and also connects with the OWL API for all importing tasks, and a PHP application named CrowdCore, in charge of orchestrating the interaction with the DL reasoners, processing the reasoning outputs for updating the KF models, and finally writing all two instances from such KF instances. Finally, we will showcase Crowd by following the shown workflow, which involves each feature of our tool. This means that we will load a UML conceptualization of an already published ontology named BigEonto, make some changes to it, and invoke automated reasoning to validate it before sharing it with other users skilled in entity relationship, ORM2, and OL2. BigEonto is an ontology designed for modeling biodiversity and marine biogeography data. Crowd's main page allows to log in into Crowd using username and password. Moreover, it shows the free UML entity relationship and ORM2 editors to start the conceptualization. Once logged in, the UML editor shows the respective palette of primitives and the toolbar with options to manage diagrams, such as save, export, import, edit them, and invoke logic reasoning. Now, the user can load our UML version of the ontology BigEonto. The model is rendered into the workspace. In UML, attributes are collapsed by default, so user can show the attributes whenever they want. Each primitive presents to users a toolkit around them. These options include delete it, connect it to others, copy it, and among others. In particular, classes can also be resized. The right panel shows more properties associated to each primitive. Full URIs enabling reuse of concepts from external ontologies and attributes along with their data types. Now, let us suppose that a UML user wants to define some new constraints between location, geometry, and spatial object, which are classes reused from the vocabulary GeoSparkUL for representation and querying of geospatial linked data. First of all, he/she defines the subclasses of a spatial object as a composed subclass, with complete and disjoint constraints. After that, she/he adds a new composed subclass involving location and geometry, and asserting them as disjoint. To see the result of his/her changes, he/she invokes automated reasoning. Reasoning option allows choosing a reasoner and add reasoning over cardinalities, since this could take much time. The reasoning results shows a new subclass between location and feature. Now, the user can edit the diagram to incorporate such changes if wanted. Similarly, let us suppose that the user add a new disjoint constraint between a spatial object and geometry. Clearly, this will produce a contradiction in the conceptualization, which should be visualized to give feedback to the user. As already said, crowd shows the contradiction. Moreover, because of other constraints, the contradiction is propagated to other primitives, such as classes, attributes, and associations. To fix the model, the user can remove the contradiction source and run the reasoning process again. Before going to other editors, the user can save the model with the last changes. Crowd will save the underlying KF instance, which can be loaded again in any other editor. A first implementation of this model can be generated by using exporting all to option. The resulting specification can be copied to clipboard or downloaded to a null file to be loaded into other ones such as Protege. To communicate this conceptualization to entity relationship users, the conceptualization can be converted to such conceptual language. Entity relationship edit shows the respective set of primitives along with the very same toolbar that the UML editor. The conceptualization, after converting it to a KF instance, is rendered in entity relationship. Each primitive shows its respective options, URIs, data types, and cardinalities. Note that the diagram includes the last changes done by the UML user. Finally, the conceptualization can be enabled for ORM2 users converting from entity relationship to ORM2. ORM2 editor presents the same look and feel than the previous ones, but now presenting a set of ORM2 primitives. Entity types, fact type, value type, and subtyping show their options URIs, frequency and roles, and data types. Finally, note that this diagram also keeps the last changes done by the UML user.